Check it.
Okay, welcome back. Today we're going to do solving systems of linear equations. This is a review of Algebra 1, so we're just going to breeze through it relatively quickly. Day 1 is going to be using something called substitution. But before we get into solving systems by substitution, let's talk about what a formula is. So take a look at these things that I have here. Which ones of these are formulas and which ones are not? We have E equals mc squared. We have y equals mx plus b. We have the very famous pi r squared, okay, the area of a circle. We have 2 pi r, the circumference of a circle. We have 2y equals x plus 3. We have the point slope form of a line here, y minus y1 equals m times x minus x1. We have 1/2 base times height, the area of a triangle. We have z equals a plus c over b. And we have 3x plus 2y equals 6. Which ones are formulas? Now, most people, if this was a normal, classroom class, I'd have people raising their hand for this because they recognize E equals mc squared. They would probably choose y equals mx plus b. They would say, hey, pi r squared, that's the formula for the area of a circle. And 2 pi r, they might recognize as the circumference of a circle. This they don't recognize, so they don't think it's a formula. Hey, this is the point slope form or formula, and they'd say that that was a formula. And then 1/2 base times height, well, that's got to be the formula for the area of a triangle. And then they don't recognize this and they don't recognize this. Well, the fact is, a bunch of the ones that I circled are not formulas. For starters, pi r squared is not a formula, but it's the formula for the area of a circle. It's not a formula in the sense that it's not written in the form of a formula, okay? And a formula, okay, you have to understand what a formula is. A formula is an equation that starts with a single dependent variable and an equal sign. So, y equals mx plus b is a formula because it starts with a single letter and an equal sign. Y equals. So yeah, that is a formula. E equals mc squared. The dependent variable, the thing that you're trying to figure out is e, and it's by itself followed by an equal sign. That's a formula. The point slope form of a line is not a formula because it doesn't start with one letter. It starts with a bunch of stuff here. Y minus y1. So no, that's not a formula. 1/2 base times height. It's not an equation. Where's the equal sign? To have an equation, you need an equal sign. So that's not a formula. Neither is 2 pi r. You need an equation. Okay, that's the operative word here. A formula is a type of equation. And if you don't have an equal sign, you don't have an equation. This random thing here, z equals a plus c over b, as random as it is, it's still a formula for the letter z. There's your dependent variable, equals, z equals. So a formula is anything that starts with a single letter equal to. Now how about this over here? 2y equals. Well, it's not y, it's 2y, so it's not a formula. How about if it was negative y? Still not a formula. It has to be just the variable, the dependent variable, and an equal sign. How about 3x plus 2y equals 6? This is the equation of a line, but it's not a formula. Whereas this equation of a line is a formula. So the only ones that are formulas here are the 3 that I boxed or circled here. Okay? So that's what a formula is. Independent variable, equal sign, bunch of stuff on the other side. The expression on the other side determines what this is going to be. This is a formula for E, this is a formula for Y, this is a formula for Z. Okay, so now we're going to get into what a system of linear equations even is, because we're going to be solving systems of linear equations. Well, what the heck is a system of linear equations? A system of equations. Well, first of all, an equation is a thing with an equal sign. Okay, there's an equal sign, and there's the right side of the equal sign. There's the left side. The right side of the equation is an expression, and the left side is an expression. So something without an equal sign is an expression. So basically, that's an expression. That's an expression. That's an expression. And if you take two expressions and stick an equal sign in between them, you have an equation. Okay, so you know what an equation is. These are linear equations because they're equations of lines. The blue equation on top here is the equation of this blue line here. And the red equation down here is the equation of the red line up here. And if you remember how to graph y equals mx plus b, you know that these are in y equals mx plus b form. And the m is the slope and the b is the y-intercept. So for the blue line, the y-intercept is 7. That means you're starting at 7 right here. That's your y-intercept. And then your slope is negative 2 over 1, right? So down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. And then for the red line, Okay, there's no number where the slope is. You might think it might be a 0, but if that was a 0, there wouldn't be an x, because 0 times x would be nothing, right? No, it's got to be a 1. Okay, so if you don't have a number here at all, it's a 1. So the slope is 1, and the y-intercept is 1. So here's your y-intercept at y equals 1 right there. And then you're going to go up 1 over 1, up 1 over 1, so on and so forth. So we have two linear equations here, and they're on the same graph. If you put two functions on the same graph, that's a system of those functions. Now these happen to be linear equations, so we have a system of linear equations. The word system is synonymous to group. We have a group that are on the same coordinate plane. Now why is that important? If they're on the same coordinate plane, then this x and this x are the same x, this y and this y are the same y. So what happens to one affects the other, and so on and so forth. So what is it? That's what a system is. A system is a group of equations on the same graph or on the same coordinate plane. What is the solution of a system? We say that we can solve a system. Well, what does that mean? It's just two lines sitting on the same graph. What's there to solve? Well, the place where they meet, the place where they intersect, the point where they intersect is the solution of the system. So you can see here, there is a place, and I'm going to zoom in on this now. There is a place where these two lines intersect, and it looks like it's happening at x equals 1, 2, x equals 2, and y equals 1, 2, 3, y equals 3. So the solution is 2, 3. That's the solution to this system here. And that's doing it graphically, meaning just by looking at the picture. You can see where they cross. Now, are we always so lucky that it lands exactly on a point? Not always. I mean, sometimes, just to show you how that, this can happen here. What if I had moved this line a little bit like that? Okay. And now suddenly, zoom in. It's not exactly 2, 3. It looks more like, I don't know, maybe 2.4, comma, it looks like 3.5. But at that point, you are just guessing. You're ballparking based on what you see. And that's why solving a system by graphing is not always a great idea, because you can't really tell with any kind of certainty what the exact points are. Even when I put this line back here, watch this. I'm going to put the line back where it was, right there. Okay, I tried really hard to make it look like it was going through 2, 3. But if you zoomed in enough, could you really tell me that it wasn't 2.03, 3.01? No, you couldn't. So with a graph, you're estimating, no matter what, you're eye estimating. Okay, so what we're going to do today, we're going to solve systems algebraically, meaning we're going to do it with the actual letters and get an exact answer, rather than look at a picture and kind of guess. But if you're asked to solve a system by graphing, graph the two lines and look at where they cross, just like I just did. But if you're asked to do it algebraically, you're going to have to use either substitution or elimination. Those are the two things you learned in Algebra 1. So this section is actually an Algebra 1 review. We're not going to spend a lot of time on this, but we're going to revisit substitution and elimination. Okay, so that's what a system is, and that's what the solution of a system is, and that's how you estimate a solution by graphing. Let's go on to two special cases for solving a system. What if you have two lines that have the same slope? So this is y equals negative 2x plus 7, and this red one here is y equals negative 2x plus 1. They both have the same slope, negative 2, negative 2. When two lines have the same slope, we say they are parallel. Well, where do these two parallel lines intersect? They don't. So we say this system has no solution. And a system that has no solution is referred to as an inconsistent system. Okay? So it's easy to spot an inconsistent system on a graph because you look at them and you can see, hey, these are parallel lines, or at least they look parallel. How do I know for sure they're parallel? Well, I need the equations. And if the equations show me that they have the same slope, then I know they're parallel. This, it is possible that this has a slope of negative 2 and this has a slope of negative 1.99. They would look parallel to the eye, but they actually wouldn't be parallel. And in which case, at some point, somewhere way off the graph, they would intersect someday. But I know these will never, because they definitely have the same slope. Okay, what about this over here? Now this looks like only one line, but if you zoom in and take a look here, there's actually a blue line and a red line, and the red line is sitting on top of the blue line, and they're otherwise identical. They're exactly the same line. One's just sitting on top of the other. Okay, you can even see it kind of over here, red and blue. So if you look at the equations do look different. Okay, this one's in y equals mx plus b form, and this one's in what's called ax plus by equals c form. This is called standard form. So you have slope-intercept form up here, you have standard form down here. But when you graph them, they are the same line. They are identical. Okay, so what's the solution to this system? Okay, the solution is where they touch. Well, these two are touching each other all the time. They're always in contact, always. So we say this has infinitely many solutions. Okay, some people might just say infinite solutions. And if you have infinitely many solutions, it's because the two lines are the same line. You basically have one line sitting right on top of the other. And if that's the case, we call this type of a system an identity. And an easy way to remember identity is that the two lines are identical. Okay, the two lines are identical. This system is called an identity. It has infinitely many solutions. So these are the two special cases of solving a system. Most of the time, there's one point where they cross, and that's your solution. In the case of the last problem, 2, 3. But you might also have an inconsistent system, which means the two lines never touch because they're parallel, or you might have an identity where the two lines are the same line, okay, and you have infinitely many solutions. Okay, so that's the background. Now that we know what a formula is and we know all the special cases, let's go back to Algebra 1 and learn how to solve systems by substitution. Now, to use substitution, one of your equations needs to be a formula. 100% needs to be a formula. So the question you have to ask yourself is, do I have a formula? Let's look at the first example here, okay? Now this first example, we have y equals, and we have y equals. So the truth is, they're both formulas, okay? So do I have a formula? Yes. In fact, I have two formulas and I get to choose which one I want to use. So let's say for argument's sake, I want to use the top. If I want to use the top formula, here's how you use it. You identify the dependent variable, which is y, and what's on the other side of the equation is the thing that y equals. So according to the top formula, y equals this thing here in the box. Okay, and now this is how substitution works. Since you're on the same coordinate plane, these have to be the same y. So if this y equals negative 2x plus 7, then so does this one. That means you can take this negative 2x plus 7 and you can plug it in or substitute negative 2x plus 7 for this y. If you do that, watch what happens. Here's your negative 2x plus 7, then you have your equal sign, and then you have your x plus 1 here. So you went from having two equations to one equation. And by doing that, you don't have any y's left. No more y. Now, why is that useful? Because you've eliminated one of the variables, you can now solve for the other variable. See, you cannot solve an equation that has two variables in it. You can't solve y equals negative 2x plus 7. You can graph it, but you cannot solve because you have two different letters. So no matter, solving means getting x by itself. Well, if you get x by itself, your answer is going to have a y in it, and you don't know what y is, so you're kind of stuck. So you cannot solve an equation with two different kinds of letters in it. However, by doing this thing called substitution, we get rid of the y, and now we have nothing but x, and we can solve that. Okay, so how do you solve an equation like this? Well, Algebra 1 style, you just get when you have x's on both sides of an equation, you get rid of the smaller one first. That's a good rule of thumb. So let's see, you got negative 2x and positive 1x. Negative 2x is smaller, it's lower. So I'll get rid of it. How do you get rid of a negative 2x? You add 2x to it and it goes away because they cancel out. But of course, if you add 2x to one side, you have to add 2x to the other side. And now what do we have? We have 7 equals, what's 2x plus 1x? It's 3x plus 1. Okay, and now you have a simple Algebra 1 equation. You subtract 1 from both sides, you get that. You divide both sides by 3, you get 2 equals x. You flip it around because you want your answer to have the x on the left. X equals 2 is your answer here. Now, is that your answer? Completely. No, it's not. Because if you remember, what we're looking for is, on the graph, where do these two lines, and they're both lines, where do they intersect each other on a graph? X equals 2 is not a full coordinate. I need to have the coordinates, remember, like we did over here, I need to have, right up here, we had the coordinates 2, 3. So our answer needs to look like an ordered pair. It needs to look like coordinates like that. So I have the x, I don't have the y. Okay? And what you learned in Algebra 1 is if you have the x, plug it in, you find the y. Now where do I plug it in? Well, the truth is, into the formula. Okay, and we actually have two formulas, so you get to choose which one. It doesn't matter which one you plug into because you're going to get the same answer because it's the same point. Okay, so if you plug x equals 2 into the bottom equation, you get y equals 2 plus 1, which is 3. So y must equal 3. Okay, so your answer is 2 comma 3. Hey, what do you know? Same answer as the other question. Now, what if I use the top one instead? What if I hadn't used the bottom? What if I had used the top? Well, plug a 2 right here. You get y equals negative 2 times 2, which is negative 4, and negative 4 plus 7, negative 4 plus 7 is like 7 minus 4. It's also 3. So either way, you get the same answer. So the first step is called substitution. When you take the formula part, the expression on the opposite side of the formula, and you plug it into the variable on the other equation, that gets rid of your y. And then you get your first answer, and then you take that first answer and you plug it back in. That's called back substitution to get your second answer, which is the y. Okay. Now, if you had solved for y first, then you would back substitute to find x. Let's try this next one here. Do I have a formula? And the answer is yeah. The bottom equation is a formula because it's y equals. The top is not. Yes. The top is not a formula, but the bottom is. And according to the bottom formula, y, the dependent variable, equals 3. So I can take this 3 and make the argument that if the bottom y equals 3, then so does the top y. So what does that give me? 5x plus, there's the 3 we're plugging in, we're substituting, equals negative 2. And now take a look. How many letters are in here? Just x. We can solve this. Okay, so real quick, you just subtract 3 from both sides to get rid of that, right? You get 5x equals negative 5. Divide both sides by 5. And you get x equals negative 1. Okay, am I done? No, because my answer needs to be in ordered pair, something comma something, the coordinates of where these two lines, and they're both lines. This is a horizontal line, y equals 3, and this is a oblique regular line, you could graph if you wanted to. So we're not doing it by graphing, we're doing it algebraically. We know this is negative 1, what's my y? So usually you would take the x here and plug it back in, but you don't need to because once again, y equals 3, it's right there. Okay, so if you use the bottom one, you already know y equals 3. Now, you could plug it into the top, and 5 times x is 5 times negative 1. That's negative 5 plus y equals negative 2. Then add 3 to both sides. Sorry, add 5 to both sides, and you do get y equals 3. It works exactly the same way. So there you go. There's your answer. All right, one more of these. Hopefully this is coming back to you from Algebra 1. This time I didn't use x and y, I used a different letter scheme. But once again, the strategy is the same. Do I have a formula? Yes, I do. I have a formula for s right here. And the formula for s tells me that this s right here equals what? It equals 3t plus 8. Well, here we go again. If the bottom s is 3t plus 8, then so is the top s. So 3 times that s plus t equals 4. I'm going to basically plug in wherever I see an s in this other equation here, I'm going to plug in 3t plus 8. So in order to do that, I need to use parentheses because this is more than one thing here and I'm plugging it in here. So it's going to be 3 open parentheses. This is where the s used to be. Okay? T equals 4. Now, this right here, we're going to substitute, instead of s, we're going to have 3t plus 8. Now, the reason why we need the parentheses is because we're multiplying 3 times this entire thing, which means we need to distribute. So there you go. Okay? Now, 3 times 3t is 9t. 3 times 8 is 24. Plus t equals 4. And, this is an Algebra 1 question again, but you have to combine like terms before you start it. I have a 9t and a 1t, so that's 10t. Plus 24 equals 4. And now just solve as usual. So here we go. Subtract 24 from both sides. You get 10t equals negative 20. Divide both sides by 10, t equals negative 2. Am I done? No. Because I need to have s as well. There are 2 letters here. There's t and there's s. So how do I find s? Well, the good thing about substitution is you have a formula for s right here. The bottom formula is a formula for s. So use it. Okay, use the formula that you have. So s equals 3, here's where the t is going to go, plus 8. Now what did we say t was? We said t was negative 2, so plug that negative 2 in there. So s equals negative 6, 3 times negative 2 is negative 6, plus 8, s equals That's going to be a 2 right there. So now how do you write your ordered pair? Because it's not x comma y. Do I write -2 comma 2 or 2 comma -2? Which way do I write it? The answer is go alphabetical. X and y, x comes before y in the alphabet, right? It's alphabetical. So in this case, s comes before t, so it's going to be 2 comma -2. And there you go. Okay, in this next example, we don't have a formula. So what do we do when we don't have a formula? Well, we can do substitution by sort of force under certain conditions. Okay? So take a look here. Is this a formula? No. Is this a formula? No. Neither one of these are a formula. However, you could, with a little bit of work, make a formula out of one of these pretty easily. Okay? The top one, not so much, because there's a 3 in front of the x and there's an 8 in front of the y. The bottom one here has this y by itself, okay? And you can get that y alone on one side of the equation and create a formula. So with a situation like this, you could force there to be a formula, and then you can go and use substitution as usual. So let's see about this here. There's the y, it's by itself, but well, it's not by itself. It's 6x plus y. So how do I get it by itself? You get rid of the 6x. How do I get rid of the 6x? You subtract it. That'll get rid of the 6x. But of course, if you subtract 6x from the left side of the equation, you must also subtract 6x from the right side of the equation. And what that gives you is y equals, okay? And you can write it either direction. You can either write -27 minus 6x, or if you want to keep it in y equals mx plus b form, you put the 6x first, -6x, and then -27, like that. Either way, you have your formula now. Okay? So you now have a new system that you can look at. The top equation didn't change, but the bottom equation is now, and then you look at that and you go, do I have a formula? And the answer is this time, yes, I do. Where's the formula? It's this equation down here. What is the formula telling me? The formula is telling me that it's, well, first of all, it's a formula for y, and it's telling me that y equals this thing right here, -6x minus 27. And then once again, the argument with substitution is to say, well, this is the same coordinate plane, so if this y equals -6x minus 27, then so does this y. So you can take this expression here, this -6x minus 27, and plug it in for y up here, and that's going to get rid of all of your y's. Here we go. 3x plus 8, and here's where the y used to be, right? Okay, so I just copied the top equation, but where the y used to be, I put an empty set of parentheses. Now, instead of saying the words empty set of parentheses, I'm going to use the expression blank. I'm just going to say 8 blank. So we have 3x plus 8 blank equals 9. And what goes in the blank? The thing that we said y was. So y is -6x minus 27. Now look at that. Do you see any y's in that equation? No, we successfully got rid of all the y's. We eliminated the y's and kept the x. All right? That means this is now a solvable equation, unlike these two where there's a mix of x and y and you can't solve them. So let's go ahead and finish this up. First thing you're going to do is distribute the 8 here. So you get, this is still 3x. This is going to be -48x. 8 times 27 is 160 plus 56, so that's going to be -216, and equals 9. So let's see, what's 3x minus 48x? It's going to be -45x. And then -216 equals 9. We need to get the x by itself, so we'll get rid of this 216. It's negative, so we'll put a positive 1 underneath, which will cancel it out. Now we have -45x equals, that's going to be 225. We're going to divide both sides by -45 to get the x by itself, and we get x equals -5. Okay? Is that our final answer? No, because remember, we have to have a coordinate pair. We have to have coordinates of where these two lines intersect on a graph. So our answer is going to be -5 comma something, but what, we have the x, what's the y? Well, the beauty of substitution is that you always have a formula for the thing you're looking for at the end waiting for you here. So we have the formula for y, so just use that. Y equals -6 blank, that's where the x is going to go, minus 27. So what did we say x was? We said it was -5, right? So this is y equals -6 times -5 is positive 30 minus 27, which is 3. And there we go. Those are our two answers. Our final answer, alphabetically, x comma y, is -5 comma positive 3. And there we go. Okay, so that's called forced substitution, where you don't really have a formula, but you can create one. And you can't always do this because sometimes you get into fractions and nasty stuff, but on all the questions that can be done by substitution, you can do this without running into fractions. For this next one here, just take a look. All right, where is your formula going to come from? Well, the bottom equation doesn't have any letters that are alone, so you're not going to use the bottom equation. The top equation does have an x. Okay, that x could be isolated and create a formula. So take that equation, come over here, and now get the x by itself. Well, how do I do that? Well, I need to get rid of this negative 7y. To get rid of the negative 7y, I just put a positive 1 underneath. Negative 7y plus 7y is going to cancel out. And I get that, plus 7y over here as well. And now I have x equals, this is 11 plus 7y, or 7y plus 11, it doesn't matter. And that's your new top equation. The bottom equation is going to stay the same. And you can see that this is the same type of system that we had before when I asked, do you have a formula? And you could say yes. So here we go. Where's the formula? It's the formula for x. What is it saying about x? That x equals 11 plus 7y. Well, if the top x equals 11 plus 7y, then so does the bottom x. So we can write this 5, but instead of x, we'll leave a blank. So 5 blank. Here's the rest of the equation. And what goes in the blank is this 11 plus 7y. And now you can solve this. Well, we're going to have to distribute here. So we get 55 plus 35y plus 4y equals negative 23. Combine like terms. This is going to be 55 plus 39y equals negative 23. We need to get the y by itself. So let's get rid of this 55 here. So now you have 39y equals, this is going to be 78, negative 78. And if you divide both sides by 39, which you have to do to get rid of this 39, 78 divided by 39 happens to be 2. So y equals negative, there's a negative there, negative 2. So we found y. What we don't have this time is x. But once again, because we're doing substitution, we have a formula for x waiting for us for that second step. So here's the formula for x. It's always going to be there when you're doing substitution. So x equals 11 plus 7y. I'm going to write 11 plus 7 blank, and then where the y was, we're going to plug in what we got before, which is negative 2. And now we have 11, this is negative 14, 11 minus 14 is negative 3. So my answer is not negative 2 comma negative 3. Alphabetically, it's negative 3 comma negative 2. Don't be fooled by the fact that we found y first. Okay, it still has to be alphabetical. So x is negative 3, it goes first. Y is negative 2, it goes last. Okay, one last example here. Now this one, if you look at it, it doesn't have any letters that are alone. Okay, like in the last two questions, there was one variable here. There was the y here that was all by itself, or at least it didn't have a coefficient, right? And there was the one over here, the x, that didn't have a coefficient, no number in front of it. Okay, that was the giveaway. But here, none of these four letters is by itself, meaning it doesn't have a coefficient. They all have something in front of them. So you might think, okay, I cannot make a formula from this. Well, this is kind of a special case. Usually for these types of formulas, you wouldn't use substitution. You would use something called elimination, which we'll talk about in the next lesson. But actually in this special case here, if you really had to use substitution, you might notice that it's actually possible to get one of the letters by itself and not get any fractions. So for instance, if this were a 2 right here, okay, then there's no way to use substitution here without getting fractions. Because let's say you tried to get the x by itself. You have to get rid of this 9. To get rid of this 9, you have to divide everything by 9. And that creates all kinds of fractions. This would be fine, but then these would both be fractions. No good. And let's say you were trying to get the y by itself. Well, to get the y by itself, you need to divide everything by negative 2. Well, you can see that creates fractions. 9 over 2 is not going to be an even number, or a whole number rather. So that doesn't work. But because there's a 3 here, okay, that's the actual question that I have here. You could realize that, hey, you know, all right, if I divide everything by 9 to get rid of this 9, I'm creating a fraction here of 3/9, which is going to be 1/3. No good. But if I divide everything by this negative 3 to get the y by itself, divide this by negative 3, divide this by negative 3, and divide this by negative 3, those are all going to be whole numbers. 9 over negative 3 is negative 3. So this becomes negative 3x. This just cancels out, giving me plus y. And this becomes positive 11. So if you can get away with that without if you can do that without creating any fractions, that's a possible way for you to use substitution here. Now the bottom one is completely useless because you have 6 and 5. Divide everything by 6, that's fine, but now you got 5, 6 over here, no good. Okay, divide everything by 5, that's good, but now this is 6/5, which is no good. So the bottom one, no good. And if you had two equations where it was no good, I would say don't even try to do substitution. We're going to use elimination for those. However, for this top one here, we saw that if you divide everything by 9, it doesn't work. But if you divide everything by 3, it does work. And actually your goal is to get this to be a positive y, so I divided by -3. So I just divided everything by -3, -3, -3, and this is what I got. So that creates this. Now this needs to be morphed into a formula. Okay, so how do I get a formula? Well, I need to get rid of this -3x and get the y by itself. So we'll add 3x to this side, that'll get rid of it. But of course you must do that to both sides. So you have y equals 11 plus 3x, and there's your formula finally. Okay, now once you have a formula, you can do substitution. Let me rewrite the problem now over here. You don't have to do this necessarily, but I just want to do it to be neat here. Okay, so there it is now with my new with the formula that I derived from here on the top and the bottom just as it was. And once again, here we go. Where's the formula? It's right here, formula for y. What do I know about y? Y equals 11 plus 3x. Well, if the top y equals 11 plus 3x, then so does the bottom y. So I'm going to write this out, 6x plus 5 blank, because that's where the y used to be, equals -8. And what goes in the blank? The 11 plus 3x. And then solve from there. So we'll distribute the 5. We'll combine like terms. Well, this is 15x. We'll combine like terms. We have 6x and then the 15x, that's going to be 21x plus 55 equals -8. We can subtract 55 from both sides, and we get 21x equals, that's going to be -63. Divide both sides by 21, and we get x equals -3. Am I done? No, I need a y. Well, where do I get my y from? There's a formula waiting for me for y. It's always there if you do this the right way. So y equals 11 plus 3x. We're not going to use x, we're going to use blank. And we know that x is what? -3 down here. So this is 11 plus -9, or just 11 minus 9, which is 2. And my final answer is x comma y, it's -3 comma 2. This is the place on the graph where the two lines intersect at -3 comma 2. Okay, that's what this means. Keep that in mind. Okay, we are done. I'll see you at the next video. Check this.